Okay, so here is the syllabus copied from SEAB lah, huh? These are the topics you need to know, okay, for differential equations. You start off with part one. You need to be able to solve for y, okay, from dy by dx equal to f of x. All you need to do is to integrate. Normally, I think you already know this. Then the next version, part two, it's when you have f of y. Notice that this is now y, not x. So this one requires something called separation of variables. Basically, you need to divide the f of y over. I'll demonstrate it as I go through some examples later. And this third one is just telling you d2y by dx squared. That's the second derivative equal to f of x. Then if you want to find solve for y, you just need to integrate. But this time you need to integrate 2 times. Okay? Yeah, that's for part one. I think you know this. Then for part point 2 and point 3, what you need to do is forming a differential equation from the problem. So basically you have to translate the English story into a differential equation. I think this is what you mentioned you have difficulties with, right?
Yes, that one.
Vectors. Yeah. I'll go through some of them in the last few one. But yeah, and these two are actually really the same point. Okay, yeah, then I'll just begin. Okay, let's take a look. Topic 8, this one, question 1. Given a differential equation, our first few questions I'll be going through, right? They will be just a recap on how to do what do you call it? How do you solve differential equations without setting up the equation? Only the last few, then I'll go through some applications, like the setting up the differential equation from the story. Okay? Okay, yeah, let's begin. So question 1, given the differential equation dy by dx equal to 1 minus y over 2, find the general solution for y in terms of x. Hence, find the equation of the solution curve that passes through the point 0, -1. So this is what we call the initial condition. You just need to sub in x equals to 0 and y equals to -1 at the end. So let's begin. Let me just show you my working that I've done previously so I can save a little bit of time. So what you start off with is this. dy by dx equals to 1 minus y over 2. You can combine it into 2 minus y over 2. Is this part okay?
Yeah, this one okay.
Okay, then what you do next is, whenever you see that it's a y, which is the dependent variable, what you need to do, you divide over. Okay, so it means you get 1 over 2 minus y, but there's a remaining 1/2. The 1/2 will just remain on the right side. And what you can do is you can integrate both sides with respect to x. Okay? Then as a result, the dx cancel off, you're left with integral of 1 over 2 minus y. That's just ln. But take note that there's an extra negative sign, so you have to divide by a -1 in front. 1 over -1, right? Integration. Then this one, integrate half, you get half x. But don't forget there's a plus c, arbitrary constant. May I know, did you take A max in O levels?
Yes.
Yes, you did. Okay, then this should be familiar to you, hopefully. Plus c. Okay, can. Then next, you have to bring the negative over, so you get multiplied by -1 throughout, so -1/2, -c. Okay? And after that, how do you go from this to this A? Let me show you some working. So what you can do is, whenever you have a ln, right, you bring it over, it's really just e to the power. Or in other words, ln of 2 modulus 2 minus y equals -1/2 x minus c. You can raise both. You can take e to the power of both of them. What happens when you have e to the ln?
Cancel out.
Cancel off. Yes, exactly. You're just left with modulus 2 minus y, which is e to the power of -1/2 x minus c. But if you remember your exponential rules from Emacs, it's -1/2 x times e to the power of -c, right? Okay, then now you have modulus, absolute value. How do you open up the modulus? What do you need in front?
So plus minus.
Yes, correct. So plus minus, then you just copy down that expression. E power -1/2 x times e power -c. But wait a minute, you realize, actually you can rewrite this as plus minus e power c times e power -1/2 x. This part here is just a constant, right? So what we can do is, we can say a times e to the -1/2 c, where we sub, or not sub, let a equals to plus minus e power c. You sort of absorb all the constants into one single letter. Okay?
Okay.
That's how you get this part. 2 minus y equals to a e power -1/2 half x. Then you want to solve for y. Minus y bring over become plus y. This one bring over becomes a minus. So 2 minus ae negative half x. This part okay? Do you need more elaboration?
This one can. Yeah.
Can okay, good. Then that's your first equation. But we're not done yet because we still don't know what is a. So go back to the question now. What did they say? They told you this solution curve, meaning the y that you're trying to solve for, it passes through this specific point. So what do you need to do?
Sub in.
Exactly. Sub in x and y, 0 and negative 1. So let's take a look. Sub in 0, -1. So we get -1 equals to 2 minus a times e to the power of negative half times 0. So what do you know about anything to the power of 0?
Is 1.
It's 1, exactly. So this guy here, e is just some number to the power of 0. So it's just a 1. So a times 1 is just a. That's why I left it as a. Then the others I just copy down. So -1 equals 2 minus a. Solving, I get a equals to 3. Is that okay?
Yeah.
Okay, good. Then we just sub in the a, then we get 2 minus 3e power negative half x. This is a recap. I think you know how to do this, right? This one is called separation of variables.
Yeah.
Okay so far?
Yeah.
Okay. Next. Oh yeah, actually I got a question up. For the prelim paper that you sent me, the RI one, did you do all of that on your own? The black pen?
No. It's like I got stuck at quite a few, so like I will like look at the answer, then I try to do it again.
Oh, I thought because a bit funny. If you actually did all this on your own, then you shouldn't be getting an S. If you're able to do so.
Oh no.
Yeah. So, you refer to the answer key. Okay. Okay. That makes more sense. All right, Ken. Then let's try another one. This one, dy by dx equals 1 minus y squared. Okay, they gave you y equals 0 when x equals -1. So you want to solve for y. How? Let's just copy down the question. Dy by dx equals 1 minus y squared. So it's over here. Okay. Then what we do? This is a y. So can we just integrate normally?
Cannot.
Cannot. So we have to bring it over. So divide. So 1 over 1 minus y bracket square. Then times dy by dx. Then we have to integrate both sides with respect to dx. And you realize that the dx can cancel off. So you're left with integral of 1 over 1 minus y bracket square dy. Okay, maybe I add in one more step. It should be add in one more line. It should be simplified as integral of 1 over 1 minus y bracket square dy equals to integral of 1 dx. Okay, then over here, what you realize is that this is just a power you can bring on top. So you get over here, power -2. Then how do you integrate? Add 1 to get the new power, divide by that new power. But wait, inside there's also a minus sign, 1 minus y, so you have to divide by -1 because of chain rule. Is this part okay?
Yeah.
Can Okay,
Can.
good. Then -1 times -1 gives you +1. So I can just sort of ignore the denominator already. This is power -1, so you can rewrite it in positive powers. So it's 1 over 1 minus y. This is what I get over here, 1 over 1 minus y. Then integrate 1, I get x. Don't forget the plus c. Then how do you make y the subject? First, I flip the fraction on both sides, and then I make y the subject. Okay, minus y bring over become plus y. 1 over x plus c bring over become minus 1 over x plus c. This is my y. But note that there is still a c. In this question, what else did they give you?
The coordinates.
Okay, maybe, sorry, you can't see a question. This one. They gave you y equals 0 and x equals -1, right? So you can sub in, x equals -1 and y equals 0. Okay, so do that. So that's what we do. X equals -1 and y equals 0. So we can just sub in y with 0, x with -1. Then solving for c, we are able to get c equals to 2. Do you need me to explain? Or you want to?
This one is okay.
Okay, yeah? Can. Then after you got your c, then you can just sub in and you get this, y equals. Okay?
Okay.
Okay, next one. Let's try question 3. This one is involving substitution. It is still in the syllabus. Let's take a look over here. They said, including those that can be reduced to part 1 and part 2 by means of a given substitution. So what this means is you need to use a clever substitution the question will give you, and then from there you need to reduce it into part 1 and part 2. And then you are able to solve. Maybe that doesn't really make sense. I just go through the question, then it will make more sense. Okay, let's take a look at question 3. I'll paste it over here. So a differential equation is given by this dy by dx equals 1 minus y over x plus xy squared. Tell me, can you do separation of variables directly here?
Cannot. There's like x there.
Correct. There is still some x's over here, so it will make it problematic. You cannot just divide by the function y to the left. So that's when you need this substitution z equal xy. And they tell you already, show that it will eventually become dz by dx equals 1 plus z squared. So how do we proceed? Let's see. So we start off with our z equal xy. And we already know that at the end of the day, we need a dz by dx. So what should we do? Just differentiate with respect to x. Then you can just use a product rule, right? Take one, differentiate the other, plus take the other, then differentiate one. Here you're differentiating x with respect to x, so it's really just a 1. So it's y times 1. So it's simplified as x times dy by dx plus y times 1, which is just y. Is this part okay?
Yeah.
Okay, good. So now let's take a look at the original differential equation we have. Dy by dx equals this guy. What do you notice? How is it similar to what we currently have about dz by dx? Maybe I should hide my solution first. Hold on a sec.
Okay.
Let me hide my solution. Don't know. How is it related? Wait, no.
It doesn't look very similar to me.
Doesn't look similar. Okay, Ken. What you need to do is to realize that you need dz by dx. So you should focus your attention to dz by dx, right, over here. But it's equal to x times dy by dx plus y. Here we got dy by dx. Here we also got dy by dx. So how do we relate them? Relate them by multiplying by our x and adding a y. What happens after we do?
Side.
To the left hand side, yes.
Oh.
Then we can eventually replace it with
the dz over dx.
Yes, correct. So that's what we're going to do. Review answer. Times x on both sides first. Then after that, distribute the x. This one, go in. 1 minus y over x, cancel off with the x. You're left with, let's see, 1 minus y plus x squared y squared. Okay? Then let's take a look. X squared y squared. Then you eventually need 1 plus z squared. So maybe this square and the square and this z square is related, right? Maybe it's related. Let's just keep going and we'll see how. I also need to plus y on both sides, right? Plus y here, plus y here. So minus y will just cancel off, or you can think of it as minus y bring over. Then you get plus y. So now I have 1 plus xy bracket square. It's the same, right? X square y square is xy bracket square.
Yeah.
Then how can I link it? How can I link it to this equation?
I can sub in the z.
Exactly. Z is xy. So I can sub in and then I will just eventually get this. This x dy by dx plus y is just dz by dx. So I can replace. This xy is just a z. So I can just replace. Okay? Shown. Then hence find y in terms of x. Now, take a look at this equation. Can you tell me what kind of equation is it? Or what method we can use?
Can do the separation of variables.
Yes, correct. So what should you do? How do you separate?
I bring over the z square, then I leave the 1 there.
How do you bring over the z square?
Like 1 over the z square.
Not very smart move. Not very good. Because you see, if you bring over, let me show you why it doesn't work. You want to bring over the z square only. The only operation you must remember in separation of variables can only, so I should write down. can only divide. Both sides by f of y. So it's like dy by dx equals to g of x, a function of x, times f of y, a function of y. Then what you do is this f of y you have to divide over. So it's 1 over f of y. It will always be 1 over f of y equal g of x. Then after that, you can integrate both sides with respect to x. Then the dx cancel off. Okay, so on and so forth. So here, if you try to bring the z square over, the y change to a z, the dependent variable is now z. It doesn't really work because you see, if you just 1 over z square, what you're doing is you're multiplying by 1 over z square on the left, so you should do that on the right as well. So 1 over z square on the right. What will you get? You will actually end up with 1 over z square plus 1. Correct or not?
Oh.
So you're still introducing a z here. So it doesn't work. You cannot leave that one alone. The alternative is, how about if I minus z square on both sides? What am I left with? If I minus z square on both sides, I'll be left with dz by dx minus z square equals to 1. Does this work?
Yeah.
No, it does not.
Oh.
When there's a minus, cannot. You must remember the separation of variable, it looks like this. After you bring the fy over, okay, maybe I add in one more line. After I bring the fy over, it becomes 1 over f of y multiplied by dy by dx. So there is only what we call a single term. No plus, no minus. Only a times.
Oh, only times.
Okay, one single term. Here, the problem is that there's a minus. So there's 1, 2 terms. Or actually, you should include a negative sign. So it's 2 terms like this. dz by dx is a single term, minus z squared another term. Cannot. So the better strategy is actually lump them all together. Then divide over.
Oh.
Like this. So divide by 1 plus z squared instead. Okay? Then after that, integrate both sides with respect to x. And I think you know the rest of the procedure. Cancel off the dx. You're left with integrating 1 plus z squared with respect to z. This is a standard formula, tangent inverse of z. Check your MF26. Okay? Maybe we should go through another lesson about integration and applications. But by this, if you're starting off with differential equation, you should already know your integration.
Okay.
Yeah, so tangent inverse, if you try to differentiate, you get to 1 plus z squared. So of course, if you integrate, you're working backwards, you'll get back to tangent inverse. Right?
Yes.
Yeah, then integrate 1, you get x. But don't forget a plus c. Okay, continue. Z will now be tangent of x plus c. And we're not done yet because the question, what was it asking? They asked us to find y in terms of x. Here we got z. That's not what we want. So what should we do with this z?
Can I sub in back the xy?
And correct, that's what you should do. That's what I did too. Sub in the xy, then solve for y. So you just need to divide by x. So y equal tangent x plus c over x. Okay, that's all.
Okay.
Yeah. So problem here is that there was no initial condition given. So unfortunately, the c cannot be found. Cannot solve for c. So this question was not so well set. NJC. Okay. Yeah, you cannot solve for c. So that's all. That's all for this question. Next one. Any questions first? Yeah, any questions?
So far it's okay. I said I never see before the dx over dx is 1.
Because okay, here right, you're just taking one, then differentiate the other. Take the other, differentiate the first guy. Then differentiate x with respect to x. It's just 1 now.
Okay, can.
Right? Okay, can. Next question. Go. Question 4. Let me copy down that question. Okay, I modified this question a little bit. Your syllabus doesn't talk about family of solution curves. It's in further math already. It's not in your syllabus anymore.
Oh, okay, good.
Yeah, good. Okay. So It's been removed from a few years already. Okay, so question 4, part 1. Find the general solution of the differential equation x squared plus 1 over x times dy by dx equals to 2. Please ignore this dot there. Yeah, so what you want to do, you want to solve for y. And if you notice this x plus x squared plus 1 over x, it's just a function of x. It's not a function of y. So do we need to use separation of variables?
Don't need.
Don't need, exactly, because there's no y. So you can actually just bring this back over to the right, and then you get x over x squared plus 1. Right? You just flip the fraction around. Is that okay?
Yeah.
Okay, good. Then you just integrate both sides. After integrating, you get to y. And of course, on the right-hand side, you still need to integrate. Oh, sorry, I shouldn't write that. You need to integrate here. And then you have to then you will get ln of x squared plus 1. Do you know how I got ln of x squared plus 1?
Yeah, because the differentiate the x square is 2x.
Correct. Yes. Okay, so you know this identity, yeah? Can
Yeah.
okay, can. Then I'll just move on. Yeah, so y equals to ln of x squared plus 1, but don't forget there's an arbitrary constant c. Okay, then also there's an initial condition given by the question, which is y equals 0, x equal to 0. Then just sub in. So sub 0, 0. Then you get 0 here and 0 here. Then you solve for c. Take note that ln of 0 squared plus 1 is ln of 1. What's ln of 1? It's just a 0 because of the logarithm graph, if you remember. There's an asymptote at x equal to 0. It intersects at 1, 0, and then it just slowly increases. Y equal ln x. Yes?
Oh, I don't remember already.
Must remember. Okay. Quick refresher on what is ln. I need a bigger graph. Ln of x is just the inverse function of y equals e power x. I hope you remember exponential.
Also
Like
don't remember.
Y equals e power x. This one actually from E math learned before already. Yeah. Exponential function is basically a function that just keeps increasing faster and faster. Okay, like here the middle line is what? Y equals what?
The x.
Yes, y equals x. And what do you notice about them? They are both mirror images around this line. Correct? That's what you need to remember. Okay, and e power x is 0, 1, then ln x is 1, 0. They'll pass through those 2 points. All right. Yeah, okay. Then ln 1 is 0. If you really cannot remember, then just use calculator. Ln 1 is 0. So you get a 0 over here. Ln 0 squared plus 1 is just a 0. Then you get 0 equals 0 plus c. Therefore, c is equal to 0. Sub in the c, you get ln of x squared plus 1. Can?
Okay, can.
Then part 3. This one. No longer in the syllabus anymore. What is part 3 asking you? Let me just bring down my question. Cut and paste it over here. Shrink it down a little bit. Okay, my part 3 is asking you sketch on a single diagram 3 graphs from the same family of curves. It is no longer in your syllabus. No longer in your syllabus. Basically, they're asking you to go and sub in different values of C and then draw the graph. Okay, this is what we call a family of curves, but not in the syllabus, so ignore this. Part 4, okay, I modified the question so that it's still in the syllabus. Describe the gradient of the particular solution curve found in part 2. What does that mean? It basically means here, y equal ln of x squared plus 1. We want to look at the behavior of this graph. And how this curve looks is like this. Sort of a horizontal line, and then it drops down and it curves towards the origin, cuts through the origin, and then symmetric. There's a mirror image like this. What do you notice as x gets bigger and bigger? What happens to the graph? At first it's increasing, then eventually what happens?
Like it plateaus, like the gradient becomes 0.
Yes, correct. You can just say that it tends to 0. Tends to 0. Or plateaus. That also works. Can. Okay.
So I use the GC to this.
Yes, you can just type in the GC to get the sketch of a curve. Sorry, I forgot to mention that.
Okay.
Use GC. Okay. Can. Next. Question 5. Let me copy the question. Okay, a curve y equals f of x. Oops, sorry, my iPad just hanged. I'm not sure what's going on. Sorry, give me a moment. Okay, back. Where was I? Question 5, right. Let me copy down the question 5 again. Copy and paste it here. Okay, so question 5. We have a curve y equal f of x. It's defined for x more than -1/3. This is just to make sure that we don't accidentally divide by 0. Huh? Make sure that the denominator, like for example, 1 plus 3x is not a 0. Okay. And it has a gradient value of 2 at the point 0, 1. Given further that the second derivative is this function, find the equation of the curve. Okay, so gradient, I will just denote it by m equals to 2. So m equals to 2 at 0, 1. And we also know the function is f of x more than -1/3, which also implies 1 plus 3x is more than 0, not 0. Then we start off with the second derivative. Then we want to solve for y. How do we do that? Just integrate 2 times. So we integrate the first time, we get back to dy by dx. Then integrate this 2 over 1 plus 3x. We'll get ln of the denominator, but don't forget to divide by 3 because of chain rule. There's a 3 here. And there's also a 2 here, so we factor it out. That's how we get a 2 over here. And at the end, we get 2/3 ln of 1 plus 3x. Don't forget a plus c. Can? This part okay?
Then no need modulus.
You don't need to put modulus of 1 plus 3x because 1 plus 3x is already more than 0.
Oh.
Technically, when you take integration of 1 over x, it will be ln of the modulus of x. Okay, you need to make sure that the x here is positive. You must have the modulus. If it's negative, ln is not defined. If you remember the ln curve just now, when x is negative, there's no graph. It's undefined. You just try quickly on a calculator, ln of -1, you get math error.
Oh, yeah.
Right? Cannot have negative inside. This one is under the topic of functions, domain and range. I don't want to go through that for now. I just need to know for ln, you must have modulus to make it positive. So here you don't need the modulus anymore because it's already positive. Right? Okay, good. So that's dy by dx, not done yet. Now we want to find y. What do? Integrate again. But before that, it's a smart move to solve for your c first. Solve for your c first, your arbitrary constant. Must have a c. Every time you integrate, must introduce an arbitrary constant. Because this is not definite integration. We never sub in upper limit, lower limit. Okay, so what is the condition they gave us? They tell us that m is equal to 2 at the point 0, 1. Or in other words, if you just ignore the 1 here, the x coordinate 0 means x equals 0 will give us m equals to 2. But if m is equal to 2, we know that the dy by dx is really just the gradient function, right? Rate of change. So we can just substitute dy by dx with 2. Okay?
Okay.
Yeah. So then we can just substitute x equal to 0 and dy by dx equals to 2. Substituting, we get 2 equals to 2/3 ln of 1 plus 3 times 0 plus c. Then let's simplify a bit more. 3 times 0 is 0, 1 plus 0 is 1, ln of 1 is 0. So 2 over 3 times 0 is 0. So therefore we get 2 equals to 0 plus c, which is just c equals to 2. Is that too fast? Can understand?
Can, for now, can. Yeah.
Okay, good. C equals to 2. Then we just have to sub back in. Then we get plus 2 here. Can?
Can.
Okay, next. Now we want to solve for y. Let's see. So in this case, a bit difficult. Why? Because what do we have here? We actually have a 2/3 ln plus 2. The plus 2 is easy. Huh? You want to integrate, you just have to, right, I realize I might have made a slight mistake here. Yeah, I have made a mistake. Hold on a second. Okay, so please don't look at the other working yet. Okay, let's take a look. So here we want to integrate this entire expression. So we can integrate it term by term. Integrate 2/3 ln 1 plus 3x first, then integrate the plus 2. How to integrate plus 2? I think you definitely know it's just a 2x. So that's why I have a 2x over here, plus 2x. Oh. Plus D. And then after that, I want to integrate 2/3 ln 1 plus 3x. So I can actually factor out the 2/3 first, and then I try to figure out what is the integral of 1 plus 3x, ln of 1 plus 3x. How do we do that? Integral ln of 1 plus 3x. Maybe I ask a simpler question. Do you know? Okay. The answer is already here. I didn't hide it. Let's say you didn't see it. Do you know how to integrate ln of x?
Is it 1 over x?
No, wrong. Differentiate ln x, then you will get 1 over x. But how about the integral of ln x?
Oh, I thought I don't need to know.
Sorry?
I thought I didn't need to know.
Why would you not need to know?
I thought don't have formula for it.
Yeah, there isn't, but you need to be able to what do you call it? Be clever enough to realize that you can actually
It's like
use
change of base or something.
no, not change of base. Not change of base. It's integration by parts.
Oh.
Integration by parts. So this one, integration by parts, right? What you need to do here is to know this trick. Ln of x cannot integrate on its own. You need a partner. You need to realize that ln x is actually just 1 times ln x. Can you see that? Ln x times 1.
Oh, yeah.
Right? So if you remember, what do you call this? Integration by parts. This is the derivation of integration by parts. And also the partner times 1. You just need uv prime equals to uv minus integral u prime v. uv prime equals uv minus integral u prime v. You know this?
Yeah. Not
Yes,
in,
okay.
yeah.
Sorry?
I do in the u dv dx, that one.
Okay. Can also. It's the same as, let me just rewrite it in that format. U of x times dv by dx equals to u of x multiplied by v of x minus away the integral of du by dx times v of x dx. Right? This formula? Yeah. How I remember is something called the Kim's D rule. Have you heard of it before?
Oh, no.
I show you.
Okay.
Okay. Let's go. So I'll just review the answer. There's a left factor, there's a right factor. Maybe I color code it. Blue and yellow. What we do? K is for keep. Oh, I need more space. Hold on. Let me just shrink it down. No, never mind. I'll just use a small thinner font. K I M S D, no space. Not well planned. K is for keep. What does keep mean? Ln of x is difficult to integrate, right? That's the one that I will keep. I is for integrate. Integrate means what? Means you look at the other guy, which is a 1, then you integrate 1, you get an x. Can? Maybe I put a k here, an I here. Then ms means what? M means minus. S means what? S means taoge. How do I draw a taoge? Something like this.
Oh.
Integral. S is for the integral. Draw an integral. So M sign is a minus, and here is the S. Draw a taoge. Okay? This is the integral symbol. Then what is D? What is D? D is for, it's an instruction. differentiate.
Oh.
Differentiate. What do I mean by differentiate? Take the other guy, you differentiate it. So just now, ln of x are very lazy, copy and paste only, never do anything. So now you have to do some work. You have to differentiate ln x, then that's why you get 1 over x. D. Then this I, maybe I put a extra L over here. IL. Maybe let me write it nicely. What does it stand for? It stands for integral. Not integrate. Take note. Grade means it's a verb. Girl means it's a noun. Meaning I just copy and paste the work that I've done previously. You see just now, I got 1. I do a lot of work, I integrate into an x. Then I don't want to do extra work. So I just copy and paste it over. Copy the integral you found just now. This guy. Okay, Kim's D rule.
Okay.
Of course, you can just use this. You can just use this formula if you find it more familiar.
I cannot remember that one.
You can start off with like the product rule in general form like this. You see, product rule means u times v. You close the bracket and then you differentiate. Prime this apostrophe here means differentiate. Then you just have to take the first guy you differentiate times the second one, plus take the first one, then differentiate the second one, right?
Yeah.
Then you just have to now integrate both sides. Integrate both sides. But wait a minute, you realize, maybe I should do it more slowly. Sorry. What I did was I made this guy the subject. Can you see? I made uv prime the subject. So I can bring this term over, then it become a minus. So uv bracket prime minus u prime v. This guy bring over, that's why we get a minus. Then you now integrate both sides. What happens when you integrate? You can split it up term by term. So yeah, so okay, maybe I need to draw one more step. Hold on a second. So I can actually get integral of uv prime equals to integral of uv with bracket, then whole thing prime. Prime means differentiate. Then you can split up the integral into 2 separate terms. So minus integral of u prime v. Correct or not?
Yeah.
But what is the integral of the derivative?
Like the original, like just the uv.
Yes, exactly, just the uv. So let me just write in one more line for you. So that means everything else stay the same. I'm gonna copy and paste this. Oh no. But this guy will cancel each other off. Can you see? Cancel off. Then you now make make this guy. Sorry, which guy? You make uv prime the subject. Oh, I forgot the integral sign. You make then hey, wait, actually that's it. That's all. This is the integration by parts formula already. Can you see?
Yeah.
Yeah, this is the integration by parts formula already. It starts from the product rule, and then you integrate both sides. Yeah. Or if you've never seen this before, yeah, this is how I usually remember it. Actually, I also remember the Kim's D rule, KIMSDI.
Yeah, I think this one is better.
Okay, I hope it helps. I'm not sure. You can come up with your own mnemonic if you like. This is just one way. Okay, so anyways, continuing, we simplify this. Ln x times x, we get x ln x. Minus sign, just copy paste. 1 over x times x, luckily they cancel off. You're left with just a 1. Integrate 1, you get x. Okay, don't forget plus c. That is for ln x. But now the actual difficult question is, how do you find ln or how do you find integral of ln of 1 plus 3x? So you do the same thing again. Do you want to practice on your own before I review the answer?
Try.
Okay, this time with 1 plus 3x. Okay, I cover up. Maybe you do you own an iPad?
No.
Okay, then never mind. You do it on paper and pen, then you can try again. Try integral of ln 1 plus 3x. I give you a hint first. You need to have a times 1. Wait, the partner times 1. Invisible times 1. Okay. can just send me on Telegram when you're ready.
Oh, okay.
Or if you're stuck, then I'll just go through to save a bit of time.
Okay, I start at the third line. Okay, I send you.
Yeah. Yes, also I think there's also something called the LIATE rule, right? If you remember.
Oh, yeah.
Like yeah, maybe I should also write this down. Okay, I received your image. Hold on, let me just write down this. I'm on my iPad screen. Am I sharing my screen?
Yeah.
Yes, okay, good. Yeah, so this one, it should be integrate, and on the right side, it should be differentiate. Because L stands for logarithm, and logarithm is really difficult to, oh, sorry, wrong way around, my goodness. L is the logarithm and it's very difficult to integrate. So it should be the one that's chosen to be differentiated. But E is very easy to integrate. So that's why it will be chosen with highest priority to be integrated. Right, that's just how you can, I think my explanation right now is not that good. I think I will explain this using the example ln 1 plus 3x. Let me just check your work first. Okay, so you decided to integrate the 1, right? So that means you have decided to pick, I think the other way that you can present this integration by parts is like this. You have a u of x and then you have a dv by dx, right? So what you decided to do is you have picked dv by dx to be 1 and u of x to be ln of 1 plus 3x. Then what do you need to do? You have to differentiate this. So u prime of x or du by dx. So this will be ln will be 3 times of 1 plus 3x. This one you integrate, it will be v of x equals to x. Then you take the diagonal, take the horizontal. That's another way you can remember this. I think most schools teach it this way. Is it correct?
They never teach me this one.
Draw a table, then diagonal and horizontal.
Oh, don't have it.
Huh?
Yeah, oh, yeah, like the diagonal thing.
Really? Okay, I thought this was quite common. All right. Okay. Let me see. So yes, your working seems fine. Yeah, it's correct. Okay, good. Yeah, your third line. Okay, your up to the third line is correct. Let me just show you. I did the exact same working. Yes. Okay. Can. But how do you continue? Here you have 3x and then you got 1 plus 3x. Do you know something called long division? I think I saw you doing that.
Yeah, long division, yeah.
3x over 1 plus 3x is improper fraction, right? The degree is the same. Degree on numerator, 3x, highest power is 1, so degree 1. 1 plus 3x, degree also 1. Right, here is degree 1. Here 3x is also degree 1. So it's improper fraction. Proper must be the numerator degree strictly smaller than the degree of denominator. So you can do long division. Or can I just show you a faster way that doesn't require long division? For the special case where it's the same degree. I just review. So actually, right, you could have rewritten it like this. Okay, I didn't show the working. I did it in my head. Okay, let me write it out. So what I'm saying is 3 over 1 plus 3x. Sorry, 3x, right? 3 times x is 3x. You can actually rewrite it like this. 3x plus 1 minus 1 over 1 plus 3x. Do you agree? Plus 1 minus 1? But wait, what's so special about 3x plus 1 and 1 plus 3x?
It's the same. Like
it's the same. Yeah, so you can actually split it out like this. 3x plus 1 over 1 plus 3x. Then minus 1 over 1 plus 3x. Agree?
Yeah.
This part and that part. Okay, then what? It cancel off. You're left with a 1 minus 1 over 1 plus 3x. And we are done. Don't need long division. right?
So
Or
it
do you
for the same power.
is the when they are the same power? Let me give you another example. Let's say you got 5x squared over, I don't know, 3x squared plus x. Okay, wait, sorry. Not just same power. They also need to have the same linear term as well and the same constant term.
Same
Okay.
linear and same constant term.
Yeah, so for example, like here you got 2x, then here you'll need what do you call it? Another x term as well. Let's say for example 4x. And then here got a constant, let's say plus 2, then here got a constant plus 7.
Okay.
I think so. Yep. Yes. But if you have linear on top, must also have linear at bottom. So let's see how we can do this without long division, how to simplify this. Maybe I'll make my life slightly easier by making this a multiple of 3. I'll make this into a 6. Okay, what you realize is that 6x squared and 3x squared. If you just divide it, it's just 2, right? 2x squared.
Yeah.
So what we can do is, I need more space. Let me just squeeze my, transfer my working over here. Actually, we could have just rewritten this as 2 multiplied by 3x squared plus 4x plus 7. Wouldn't it be nice if the numerator was actually the 2 copies of the denominator? Then we can just cancel off, right? You get a 2. But that's not the case. What we realize is that if this was actually the case, let's expand this. What do we get? We get 2 times 3x squared, 6x squared. 2 times 4x, 8x. 2 times 7, 14. Are they equal?
Nope.
So what do we need to do to compensate? You have 8x over here, but we actually got 2x. How about if I just minus 6x? Does it balance out now?
Yeah.
For the x. Then how about the constant? You actually 1 plus 2, but we currently have 14. So what should we add on or subtract? Minus 12, exactly. Draw a line. So we can actually split it out as 2, this part plus this part. So we can plus negative 6x minus 12 over the denominator 3x squared plus 4x plus 7. And there we go, we are done. No need long division. This is a shortcut. If you can see this, then it will be faster. But if you cannot, then just do long division. Let's just do a quick recap on how to do long division for this one. Very fast one. So let's see. First, you look at your leading term, 6x squared. Look at your leading term, 3x squared. Always focus on leading term of this, what we call the divisor. 6 divided by 3, what do we get?
2.
2, but x squared over x squared cancel off. So we are literally left with a 2. And now you times in. 2 times in, you get 6x squared plus 8x plus 14. That looks very familiar. Right?
Yeah.
So that's why they are the same. The procedure is the same. Then now we minus away 6x squared plus 8x plus 14 with brackets. So subtracting the 6x squared, we're left with 0. 2x, you minus away 8x, you're left with negative 6x. 2, you minus away positive 14, you're left with negative 12. The degree here is what?
Degree of 1.
1. The degree here is what?
2.
2. The degree is smaller already, then we stop. We conclude this is our remainder. So what we get is quotient plus the remainder divided by the divisor. Right? Long division. Yes?
Yeah.
This one actually from AMAX. So I assume you know this. Okay, let's quickly move back to the question. Yes, 3x over 1 plus 3x can simplify as 1 minus 1 over 1 plus 3x. So that means I can now, I just review everything. Replace this with 1 minus 1 over 1 plus 3x. Then you can integrate term by term. Integrate 1, what do you get? X. Don't forget a minus sign. Then minus a minus becomes a plus. Then integrate the second fraction. This one I think you know, it's just ln, right? Ln. Yes?
Why you need the modulus?
Oh, wait, sorry. Mistake. I shouldn't put modulus anymore. Should be round bracket. Because 1 plus 3x is more than 0 already. Right? 1 plus 3x was more than 0. Sorry, my mistake. Okay, good. Yeah, don't need modulus. Okay, can. Let me just erase the highlighter. Yeah, so that is our answer. Then we can transfer over. Transfer over here. Blah, 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 blah. Okay. So sorry, a bit messy. Let me clean up. Here we are in, go back, y equals to integral of this guy. Then the first term, 2/3 ln of 1 plus 3x means integrate. You take out the 2/3, then you multiply by the integral of ln 1 plus 3x, which is whatever is inside the bracket here. Plus 2, you integrate, you get plus 2x. Right? Plus 2 integrate, you get plus 2x. Then don't forget a constant plus d. Can? Okay. Then I think I did something wrongly here. I'm gonna delete this. Next, we need to solve for d. Why do we have a d here? It's because we are doing indefinite integration. Always have arbitrary constant d. Okay, so let's read back the question. Let's look back at the question and we realize that they gave us 0.01. So x equals 0, y equals 1. Then we just need to sub in, no? Correct?
Yeah.
Sub in. Okay, so y is now equals to this, and we can sub in 0, 1. So what we'll get, 1 equals to 2/3, multiply by 0 plus 0 plus 0, and then plus c. Why is this a 0? Because here is a x. 0 times ln x. 0 times ln 1 plus 3x. 0 times anything is just 0 lah. So we can just put a 0. Here minus x is a 0, so substitute, of course, we get 0. Then the second one, if x is 0, 3 times 0 is 0, 1 plus 0 is 1, ln of 1 is, oh sorry, wrong bracket. ln of 1 is
0.
0. 0 times 1/3 also 0. Okay, that's how we get 0. Then plus, sorry, I made a mistake here. This shouldn't be plus c. It should be plus 2 times x, which is also a 0, then plus d. Solving, I get d equals, let me see, yeah, just 1. D equals to 1. Can?
Okay.
Okay, so substituting d equals to 1, then we finally get our answer. Ta-dang. Okay, sorry for my handwriting.
Okay, it's okay.
Can I hope you can read. Let me know if you cannot read. I'll read it out. I'll rewrite it.
Okay.
Okay, then that's the answer for this one. Question 5. Next question. Question 6. Finally getting to the one that you were asking, application questions. Okay. Okay, let's go. So let me just copy the question so I don't need to keep flipping up, changing the page. Yeah, so this is the question. There is a worker, he's pouring water into some container. Okay, is it too small? Can you see? Can you read?
Can see.
Can I? Okay. Yeah, he's pouring into a rectangular tank. At time t hours, the depth of water in the tank is x meters. So I draw a tank for you and a depth x meters. Like water, so I use blue color. Okay, the tank has a horizontal base area of 2 meters square. I shaded the bottom here and I label 2 meters square. The worker's friend, he suggests pouring hot water at a constant rate of 2 meter cubes h power -1. You know this means per hour, right?
Yeah, per hour. Yeah.
2 meter cube per hour. They are the same. It's just a different notation. Okay, and pouring cold water at a rate which is proportional to the square of the depth of water in the tank. Take note that when they say is proportional, they actually mean is directly proportional. Throwback to secondary school E-math. Like let's say you got y is directly proportional. This is the symbol for directly proportional to x. What's the equation? Y equals?
Kx.
Exactly. Good. Okay, you remember. Good. Okay, then yeah, proportional to square of the depth of water in the tank. So you want to show that dx by dt equals 1 plus kx squared. How can we do that? What we can do is to figure out the rate that goes in and the rate that goes out, if there is any. Some questions, they will have water going in and water going out. So what you do is you find the rate that's going in, you find the rate that's going out, then you subtract.
Okay.
But in this question, it's simpler. There's no water is not leaking out from this tank. So water is just going in. That means we just need to figure out what's the rate in. But we realize there are two things going in, hot water and cold water. So first I figure out what is the rate of hot water going in. Let's figure that out. They tell you already lah. Pouring hot water at a constant rate of 2 meter cube per hour. So just write down 2. Then how about cold water in? Let's see. Cold water is going in at a rate which is directly proportional to the square of the depth. Depth, they tell you already over here. Depth is x meters. Can see my highlight?
Yeah.
So what we know is it will become some constant times x squared. I chose the letter C because later I need to use the K. So I don't use the letter K first. I use the letter C. So instead of Cx, it's Cx squared. Is this part okay?
Yeah, can.
Not just directly proportional to depth, it's the square of the depth. Okay, so now you want to find the total rate of change of the volume. Take note, the units here is meter cube, right? So it's volume, rate of change of volume. It will just be 2 plus Cx squared. Agree? Just plus only.
Yeah.
Hot water go in, cold water go in, so that's why you just plus. But here, the actual question is asking you to find dx by dt, which is what? The rate of change of what?
The depth of the.
Very good. So how do you find the depth of a rectangular cuboid, a tank? You got volume. How do you link it to depth?
The volume divided by base area.
Exactly. The base area is a constant too, so you just divide. So therefore, rate of change of the depth, you just take this, divide by 2. In other words, dx by dt is just 2 plus cx squared over 2. Simplify, you get 1 plus c over 2x squared. Correct or not? This part okay?
Yeah.
But c over 2 is just c is just some random constant. You divide by 2 is still a constant. So now I'm going to purposely replace it with a letter k. Then I get 1 plus kx squared. Shown. Ta-dang. Is this clear?
Oh, okay, can. But if
not
the
too-
question use K, right, then at first I cannot use K.
Yeah, try not to.
Okay.
Try not to. Yes. Make it different. Okay? Yeah. Not that bad. I hope it's not that bad. Shown.
Okay.
Yeah, just rate in, rate out only. Plus and minus. Sometimes you don't even need minus. This question is quite easy. So given that x equal to 5 when t equal 1.5, find x in terms of t. So after you set out the equation, it goes back to the exact same kind of question already we've been dealing with for the past 5 questions. Just integrate. Then you need to determine, is it a separation of variable or is it just normal integration? So can you tell me, is it normal integration or separation of variables?
Need to separate.
Yeah, separate. So can you minus kx squared? Can you divide by kx squared?
Cannot.
Cannot. Treat this as one entire thing and
Bring over the entire thing.
exactly. So you get 1 over 1 plus kx squared times dx by dt equals to 1. Actually, should I give you time to practice? Or should I just go through?
Can.
Do you want to practice? Or go through? You decide.
Later I will practice on my
Okay,
own.
10. Then we can go through more questions.
Yeah.
Yeah, okay. Yeah, you practice in your own time. I'll just go through. Okay, so integrate with respect to dt, they will cancel off. You're left with 1 over 1 plus kx squared dx. Then integrate 1 dt. Correct or not? And because okay, maybe sorry, am I doing it a bit too fast? I show a bit more working.
Okay.
What I mean is dx by dt is currently this guy here, 1 plus kx squared. So I divide by 1 plus kx squared. So it's 1 over 1 plus kx squared times dx by dt. What happens if I divide this over? I'm not left with 0. I'm left with 1. You see? Because you can think of it as 1 times 1 plus kx squared. Then I'm left with that 1. Right?
Yeah.
This one bring over. Not confused,
Yeah. Okay.
Okay, good. Then after that, I introduce the integral dt. Okay, maybe I color in green color to make sure that it's different. Just be consistent and write down a pink color 1. Then after that, the dt cancel off. You're left with integrating 1 plus kx squared dx. This one is a standard form. So you can just get tangent inverse of this guy, but divide by 1 over square root k. Can? Maybe I should remind you. On your MF26, you will get the derivative of they present it in a table format. 1 over x squared plus 1 is equal to tangent. Oh, sorry, other way around. My goodness. What's going on? Did it? Sorry, let me try again. They will tell you that the derivative of tangent inverse of x is equal to 1 over x squared plus 1. Okay. Then they will also tell you that if you try to integrate 1 over a of tangent inverse of x over a, it is 1 over x squared plus a squared. Correct me if I'm wrong. MF26. Do you have the MF26? Can you Google it?
Yeah, I have.
Right.
John? Oh, yeah, correct.
Right. Okay. So honestly, I really dislike this formula. I don't like it at all. I like to think of it like this. I will stick to tangent inverse of x. Then I will think, how about if I differentiate tangent inverse of px plus q? What happens? I can just use the same formula, but everywhere that has an x, what am I going to replace it with? Maybe I color code it.
The px plus q, the entire thing.
Exactly, px plus q. But wait, what do we know about chain rule? This is another function inside. So we need to multiply by the derivative of the inside, which is p. Correct or not? Differentiate px plus q. So you just have to times p on top. Okay, I prefer this formula because now I know if I just integrate both sides, integrate, the integral and derivative cancel off. I'm left with integral of p over px plus q bracket square plus 1 dx is equal to tangent inverse of px plus q. I prefer this formula a lot better. Why? Because I don't need to stress out about, how come here suddenly got 1 over a? How come here suddenly got one a square? Previously it was a 1. How come it turned into an a square? What's going on? Very confusing. Right? I prefer this formula instead. I simply remember there's a px plus q, so just sub with px plus q, but there's a chain rule, so I have to multiply by a p.
So is it always plus 1?
Yeah, you can always force it to be a plus 1. Okay, let's just do a quick practice. Let's say I want to integrate, for example, let me think a bit. 3 over 2x plus 5 bracket square, and then I make your life difficult. I'll choose 7. How do you integrate this? First, you must identify, plus sign, square, then must be using this formula. But wait, here is a 7, here's a 1. What should I do? My suggestion is, it's a suggestion. If you think that you can use the formula list and you find it simpler to use the formula list, it's fine. My suggestion is to use this formula, and then you convert the 7 into a 1. How? By factoring out a 7. So here's how I do it. What do I mean? I am going to let me think a little bit. Okay, in fact, actually, this formula I will also equivalently prefer this one, 1 over. Just make everything 1. You see, don't have to stress out so much. How come suddenly got 1p? Just make it a 1. Then I just have to divide by p. Okay, this part may be a little bit funny. How come got a p? How I remember it is there's a p here, then because of chain rule, I need to divide by p. Okay? Yeah. Because integration you need to divide by p. I think that's quite a common rule. Okay. Then here what I can do is I can factor out a 7, so the 3 leave alone, but the 7 I can take out from the denominator. Then I will be left with 2x plus 5 bracket square over 7 plus 1. This part okay?
Yeah.
But Now I can, how do I bring that 7 and the square? How do I bring that 7 inside the fraction? Here's a trick. 7 is the same as square root 7 square, agree?
Yeah.
So I can rewrite 2x plus 5 bracket square over 7 as 2x plus 5 bracket square over square root of 7 square. Do you remember a power m over b power m is?
Huh? Have this thing.
Exponent rules. A over b bracket power m.
Oh. Yeah.
Factor out. So you can also rewrite it as 2x plus 5 over square root 7 bracket power 2. Correct?
Yeah.
Okay, just to make it even more obvious, you can rewrite as 2 over square root 7 times x plus whatever nonsense, 5 over square root 7, not so important, bracket power 2. Okay, let me just delete this. Okay, can good. So now I can integrate. I'll just factor out the 3. 1 over, I'll copy and paste this, square plus 1 dx. Correct? Okay, then I can use the formula. This guy. If you just remember one formula like this, right? Integrate. Oh, maybe from here you can. I should write down. From here you can deduce that the integral of 1 over x squared plus 1 dx is equal to tangent inverse of x. If you just remember this one formula, you're able to roughly guess what is the answer to this integral already. You see, 1 over something square plus 1. 1 over something square plus 1. It's just tangent inverse of that something. It's just tangent inverse of that something. So this is equal to, no space, sorry. Let me just move my working a bit to the side. Sorry, let me start a new page. Hold on a second.
Okay.
And to make it look neater. Don't need to squeeze my working. Okay, I can put it to the side. Good. So what was I saying? Yes, I was saying that the integral of 1 over x squared plus 1 equals to tangent inverse of x. So you can just substitute the x with that horrible expression inside the bracket. So it becomes 3 times tangent inverse of the horrible expression. But because there is an extra term in front, that's why you have to divide by that term. So if you remember this formula here, you have to divide by p, right? Px plus q. So what is my p in this case?
Square root 7.
No. See, it's inside the bracket px plus q before you square. Inside the bracket px plus q before you square. So what's my p?
The 2 over 7 square.
P is actually 2 over square root 7. No square. Oh, so now you have to divide by p. 1 over p would be 2 over square root 7. Okay.
Yeah.
Similar analogy would be like, for example, if you are trying to integrate, let's say, cosine of 2x, what would it be?
Is it half? Like
half sine 2x. Correct. So it's similar idea. You got a p, then it become 1 over p. Correct or not?
Yeah.
Because of chain rule. So same thing here. You have a p, you have a 1 over p. So it's easier to remember. If you remember trigo, you also remember how to integrate tangent inverse. All you need is this formula. In fact, this formula maybe you can just throw away. Just need to remember this trick here about the 1 over 2. If this is like, for example, a 9, then this will be 1 over 9. Right? You just have to do the 1 over because of chain rule. Right? P, then divide 1 over P. So that's why this is a rant. I just really don't like I just really don't like this formula that was given in the formula list. Absolutely confusing. Got an a square here. Wow, I don't
I think
understand.
it's on purpose.
I don't know. I don't know if it's useful. Maybe you can find, if you find it useful when you're practicing, then you can use it as well. But for me, I usually don't. I prefer to factor out my 7 step by step until I get my px plus q. I get a 1 on top and a 1 below. Okay.
Okay.
Yeah. So then you can simplify, so on and so forth. Let's go back to the actual question. So yeah, after you integrate this out, here your px plus q, your p must be you need to realize that the 1 over kx squared plus 1, I just swap them around, 1 plus kx squared plus 1. You can rewrite as 1 over square root of k times x bracket square plus 1. Can you see?
Yeah.
The k must be rewritten as a square root bracket then power 2.
Okay.
Can Then what is my px plus q? Here. P is actually square root k, q is 0. P is square root k, q is 0. So you can just use square root k. That's why I have a square root k over here, px plus q, and then you have 1 over p. 1 over p because of chain rule. Is this part clearer now?
Yeah.
Okay, hopefully. Then yeah, just integrate 1 with respect to t, you get t plus c. But we're not done yet because now we want to solve for x. So 1 over square root k, you times the square root k over. Then you get square root of k times of t plus c, which is this part here. And then you have tangent inverse you have to also bring over. So that's why we have tangent over here. This part okay?
Yeah.
Okay, then you solve for x. So plus 1 bring over become minus 1 here. Then there's a square root k multiplied by the x. So you divide by square root of k. That's how you get x. All right.
Okay.
Okay, but we are not done yet. What did the question tell you? They told you x equals to 5 when t equals 1.5. X equals 5, t equals 1.5. So you can now substitute x equal to 5 and t equals 1.5 to solve for those arbitrary constants. X equals 5, t equals 1.5. Yes, so sub x equals 5 and t equals 1.5 into this equation. I can just cover the rest already. Oh, sorry. Actually, I realized that instead of using this equation directly, I use this equation 1 because it's simpler. Yeah, it just looks neater. You can sub in into equation 1 or you can sub in to the most updated x. Both are fine. Okay, then substituting, I get this. Right, the x replaced with 5, the t replaced with 1.5. Then I can solve for c, so I get this. So far, okay?
Yeah.
1.5 bring over become minus 1.5. Then after that, you just have to sub the c back in. So this is c, and then you have to substitute back into over here, this c here, t plus c. So t plus c. Okay, I know it's very messy, but that's what the answer is requesting. Okay, can see I highlighted the c.
Oh, okay. Wow, so long.
Yes, correct.
Okay.
Yeah. Then that's your answer. Very long. Not that easy. This one, what school is this? What school is this? PJC. Yeah, Pioneer. Before the merger. Yeah. Okay, that is on question 6. Let's. Oh, sorry. Not done yet. Question 6 is a part 2 as well. So now the worker's cousin. Okay, he thinks that the previous model, this guy dx by dt equal 1 plus kx squared, not realistic. Okay. They might even ask you to explain why he thinks it's not realistic. One possible reason is that you see, what this model is suggesting. Okay, let's just look at the x that we solved for. Is tangent of some quantity, function of t, minus 1 over square root k. What do you know about the tangent graph?
Is it like 1, -1, the range?
1, -1?
The range like, is between like 1 and -1. Is it?
No.
Okay.
No. Tangent graph, sine, cosine, tangent graph. No, it goes all the way to positive infinity, negative infinity. At x equal pi by 2, x equal negative pi by 2. Oh,
So where is that from?
from
I think
Amex. From Amex.
principal value is it?
Principal value. No, that one is tangent inverse. Tangent inverse.
Oh,
No,
okay.
this one is tangent graph, right? Let me just do a quick recap on what is sine curve, cosine curve, and tangent curve. This is sine curve, and it just copies, and you can copy and paste it a few times. Oh, it goes on forever in both directions. This is the y equals to sine of x from Amex, from O level Amex.
Yeah.
Cosine curve is down, down, up, up. Then you repeat many, many times. Not very nice, but okay, you get the idea. Tangent, tangent will be, I need more space, hold on. Tangent will be, shrink it down. Something like this. At x equals to pi by 2, which is 90 degrees, and x equals to negative pi by 2, negative 90 degrees. The graph, there is asymptotes like this. The graph will approach the asymptote, but it will just keep going down. But then it will eventually reach origin, and then it curves back up to the other asymptote. It actually goes all the way to positive infinity, goes all the way to negative infinity. Then you repeat. So let me just copy and paste this. I can do this with our iPad. So let's just do it. Copy and paste. Yeah, not very nice. Let me try again. Okay, basically it just goes on forever. Copy and paste a few times. All these asymptotes. Okay, and it's always 180 degrees gap between the asymptotes, which is pi radians, if you remember. This is actually from Emax, sorry, not Emax, Amax.
Forgot already.
Cannot forget. No. Okay, then the point I was trying to make here is that since y equals tangent x, since this is going on to infinity, what does that mean about your x value? If this tangent graph will go on to infinity when it reaches like pi by 2, right? So tangent of whatever, if this quantity gets very, very close to pi by 2, if this gets close to, I wanted to draw an arrow, but I'm afraid that you don't understand. So I'll just write in English, gets close to pi by 2. What does that mean about this tangent value? It will go closer and closer towards
Infinity.
Infinity. So your x is getting closer and closer towards infinity. Does it make sense?
No.
X is your depth of water. How can it go to infinity? Impossible. That's why that's the one possible reason why you could explain why this previous model. Sorry. Yeah, that's one reason why you can explain why this previous model is not realistic. The x may tend to infinity, which is impossible.
Oh.
Yeah. Okay, maybe you might have to explain during exam. There have been questions that asked that in the past few years. Okay, instead, the cousin suggests that the x and t should be related by the differential equation, this guy instead. 1 over 1 plus t squared. Find the general solution of this differential equation. That's the first part. Then explain in simple terms what will eventually happen to the depth of water using this model. Okay, just now this one is what we call unbounded. Unbounded. It just goes on forever to infinity. Here, dx by dt, what do you think will be the opposite of unbounded?
Like it converge to a point.
Yes, correct. It will converge to a value. I'll just give the answer is pi by 2. But let's just work it out. Why should it converge? So let's look at this differential equation. Dx by dt equals 1 over 1 plus t squared. So over here, you really just need to realize that t here is the independent variable. So do you need to do separation of variables?
Don't need.
Don't need, just integrate, and it's just a standard formula. It's just tangent inverse of t plus c. How does tangent inverse graph look?
Yeah.
GC, GC.
Oh.
You can use GC, but I'll save you some time. I drew it for you already. It looks like this. Wow, it looks very ugly. Let me try again. Okay, let me try again. So it looks more like I need more horizontal space. Here is y equals positive pi by 2. Here is y equals negative pi by 2. How does the graph look for the tangent inverse? It looks something like this. And it goes towards origin, and then you continue going down, 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 and getting closer and closer, but never touching. That's why it's called an asymptote. Y equals to negative pi by 2. These are asymptotes. Okay, but of course, actually, since we are looking at positive values of t, right? T is referring to time. Time cannot be negative, so we actually ignore this left half. Focus on the right half. So what can you tell about this graph? It's tending towards?
Tending towards like the asymptote.
But in this case, what is the equation of the asymptote?
The pi over 2.
Yes, correct. So what's the horizontal axis variable? It's actually t. How about the vertical variable? Is it y?
It's x.
Very good, it's x. So it means that the x, which is also known as the depth in this question, is approaching pi by 2. Pi by 2, if you use a calculator, is around 1.57. So it's telling you your maximum height will be around 1.57 meters. Okay. So the depth will reach a maximum height of pi over 2 meters. That's the conclusion. Okay. Approaches converges. Okay. Converges towards. It actually never exactly reaches the maximum. So it's more accurate to say converges towards. So shouldn't say reaches. Approaches. Approach means you're getting closer and closer, but never actually there. All right. Yeah. So that's why it's more realistic. You have an upper limit. If not, the water will just keep flowing, going for taller and taller. It doesn't make sense. Okay. Next question. Any questions first?
No.
No, Okay. Yeah, just let me know. You can message me if you got question. Okay, question 7. Let's go on. Next application question. This one is part A is just standard question. Part B need application. Okay, let's read the part A first. So find the general solution of the differential equation d2y by dx squared equal to secant x times tangent x. Okay, so for this one, right, you need to look at your MF26. Can you see the secant x times tangent x? Under derivatives.
Yeah, it's secant x.
So if you work backwards from the integrating secant x tangent x, you should get secant x. So secant x plus c. Just use the formula list. Okay. I gave a short explanation on why differentiating secant x will give you tangent x secant x. Do you want the explanation?
Yes.
Yes,
Yeah.
You don't really need it, but I'll just explain. Or do you want to skip?
But they may test, right?
Okay, I will explain then. All right, so sorry, apologies for the handwriting. D by dx of secant x, you need to remember your what we call the complementary identities. So sine, cosine, and tangent you know already. Then cosecant, secant, and cotangent, can you remember?
Remember?
What is it equal to?
Is 1 over sine, then 1 over cosine, then is cosine over sine.
Yes, 1 over tangent. So how I remember it is like this. Co no co. Co no co. What's co no co? Co no co. It's a mnemonic. Co here, don't have co here. Don't have co here, you have a co here. Co here, don't have a co here. Yes co, no co. Yes co, no co. Here have co, here don't have. Here don't have, here have. Here have, here don't have. Can you see a pattern?
Yeah.
So 1 over, 1 over, 1 over. Then tangent x, of course, you also know that is sine x over cosine x, which means that the cotangent of x, which is 1 over tangent x, will just flip the fraction. Flip the fraction, you get cosine over sine. Yeah.
Okay.
Yeah, cool, no cool. That's how I remember it. Okay, I'm gonna move on. So this one, because it is secant x is really just 1 over cosine x. I can rewrite as cosine x power -1. Then what happens if I differentiate? Just use chain rule. -1 power, use power rule. Bring down the old power -1 to get the new. Copy down the same base, cosine x. Then cosine x, chain rule tells me I need to differentiate the cosine x. So I will get a negative sine x. This part okay? I multiply.
Yeah.
This is chain rule, times negative sine x is because of chain rule. Okay, then you can simplify. So negative and negative gives you positive. 1 can just throw away. So sine x is now on the numerator. But cosine x, special, -2 power. So you can bring it down to the bottom to get +2 power. But +2 power means there's 2 copies of it multiplied together. So I split it up. This part okay?
Speed up, but how I speed up? There's only sine.
Sorry, rewrite as cosine x times cosine x. Cosine x squared is cosine x times cosine x.
Yeah.
Can I?
Yeah.
Bring down, then become cosine x squared, which is cosine x times cosine x. The reason I did that is because I want you to see that sine x over cosine x, and there's an invisible times 1 here. Sine x over cosine x is really just tangent x, right?
Yeah.
Sorry, I didn't write an n. Oops. Okay, then 1 over cosine x is just secant x. Then just times off. That's all. Done. Differentiate secant, you get tangent secant. You may need to know this. I don't really think you need to know this actually, because it is in the formula list. So you just need to know how to use the formula list can already. Okay? Yeah. You can try this. You can do it as an exercise. Why is the derivative of cosecant x negative cosecant x cotangent x? Also in the formula list. Yeah, you can go work it out. But now I'll just move on first. Cover more content that's more relevant. So dy by dx, you integrate. Yeah, I just write down integrate. Then I get my secant x. Okay, good. Plus c. Then always check out plus c. Now you have to integrate again to get your y. Remember this one d2y by dx squared is in the syllabus. Let's just go back to the syllabus all the way at the beginning. Over here. This is part 3 now. Part 3, d2y by dx squared equal to fx. Integrate 2 times. Integrate 2 times. Okay, let me find back the question. Go back to the question. This was question 7, is it? Yeah. Okay, so integrate secant x. Then how? Oh no, I don't know how to integrate secant x. Don't worry, go back again to your formula list. Okay, if you're looking at your MF26, right? Yes.
Yeah.
If you just scroll down to the integrals part, the last line, secant x integrate, you get ln of secant x plus tangent x. Okay, so it's just formula list. But here got a tricky part. Integrate plus c. You need to integrate term by term, right? Integrating the plus c, you get cx. But you also need another arbitrary constant plus d. Okay?
Okay.
Can So now what we have is, I'll just call this I'll just label this as equation 2. Okay, wait. I'll label this as equation 2. Why did I write it a second time? Later I explain. Okay, so what we need to do now is to find the actual values. Let me go back to the question now. What did they tell you? Find the particular solution of the differential equation for which y equals 2, dy dx equals 1, x equals 0. So I just need to copy down that information. Y equals 2, dy by dx equals 1, and x equals 0. Maybe I'll just write it down. X equals 1 and x equals 0. Yeah. So then I can just substitute in to solve for my c and solve for my d. So what I did over here is I started off with equation 1. Then I replaced dy by dx with 1 and x with 0 to solve for c. Then I get this part here. 1 equals to secant 0 plus c. But what is secant of 0? I don't know what it is. I only know sine, cosine, and tangent. So I rewrite as 1 over co no co. So cosine of 0. What's cosine of 0?
Is it 1?
Yes, it's 1. So 1 over 1, then you get 1. Well, that's why secant of 0 is 1. Okay? Then 1 equals 1 plus c, so therefore c is equal to 0. This part okay?
Yeah.
Okay, good. So since I know c is equal to 0, I can sort of substitute in the c here with 0. 0 times x is 0, so I can essentially remove this term. Correct?
Yeah.
0 times x now. Because c equals 0. Oh, by the way, this one means because, this symbol, and the other way around means therefore. I am very lazy, so I like to use shortcuts. This one is because, this one is therefore. So I apologize if I didn't explain this earlier and I used it.
Oh.
Yeah, so c equals 0. That's why I cancel off this cx. So I now call this equation 2. I still need to solve for d. What do I do? Use the condition they gave you, lor. These conditions. So let's take a look. Y equals whatever. How about if I just substitute y equals 2 and x equals to 0? Can I do that? Yes, I'll get 2 equals to ln of secant 0 plus tangent 0 bracket, then plus d. Secant, secant 0 we already found out just now is 1, right? Yeah. How about tangent 0?
It's also 0.
Yes, it's also 0. If you just remember the tangent graph, here is 0, comma 0. So when x equals 0, tangent is also 0. So you replace with a 0. Then you get 1 plus 0, which is 1. ln of 1 is 0. 0, not 1, it's 0. Okay, so ln of 1 is a 0. 0 plus d equals to 2. Therefore, d is equal to 2. This part okay?
Yeah.
Okay, good. D equals to 2. So that means I can sub in the d with 2. I will get my final conclusion. Y equal ln secant x plus tangent x plus 2. Okay? Okay, good. Now let's move on to part B. Let me copy down the question so I can stop scrolling up and down. Paste it over here at the side. Hope it's not too small. Okay. Yeah, so part B, what did they ask us to do? The rate of change in the population of a colony of insects of size X thousands. Take note, here when they say X thousands, you have to be very careful. If I give you, like, for example, 10,000, the population of the colony of insects is 10,000. Then what is X equal to?
10.
Yes, very good. It must be 10. You must drop 3 zeros. Is this clear?
Yeah.
Okay, good. Can. Because it's in thousands. 10 and 10,000. Yeah, okay, so at time t days after it is first discovered, it satisfies the following differential equation. Dx by dt equals to 40 minus 0.1x. Okay, so this question is kinder to you. They didn't ask you to derive the equation on your own. They gave you the equation. So find x in terms of t given that x equals 300 when t equals 0. Okay, so same thing lah. Here you need to integrate. Here you have an x. So do you use separation of variable or do you use normal integration? Separation of variables, right? Because this is dependent. So here I did a trick. I factored out a 0.1 to make my life slightly easier. Factoring out 0.1 is the same as 1 over 10. So this becomes 400. 40 becomes 400. Right?
Oh, okay.
Yeah, 0.1 times 400 is 40. And then factoring out the 0.1, I get minus 1x. So just minus x. Okay. Then I leave the 0.1 alone. 0.1 is multiplied by this 400 minus x. Then I divide the 400 minus x over. I'm left with 1 over 400 minus x times dx by dt equals to 0.1. And then I introduce my integral. Integrate dt on both sides. Dt cancel. You're left with integral of this dx. This is just ln with modulus. And there's a minus, so you have to divide by a negative 1. Like 1 over negative 1, which simplifies to just negative. Okay?
Okay.
Then integrate 0.1, you get 0.1t. Don't forget the plus c. Okay, good. Not done yet because we need to sub in initial condition. What's the initial condition? Can you tell me?
x is 300 when t is 0.
Exactly. So you just sub in those values. X sub in with 300, t sub in with 0. 400 minus 300, you're left with 100. T sub in with 0. Then it's just 0.1 times 0, which is just a 0, plus c. Negative sign. This part okay?
Yeah.
So c is equal negative ln 100. Okay, sorry, handwriting. Ln. Oh, then you just sub in the c, then you'll get this equation here. The plus c replaced with negative ln 100. Okay, then do you wanna, can you try? I think you should practice this. Can you make x a subject? Try. Paper and pen. Oh. Yeah, so starting from this equation, then make x the subject.
Okay.
When you're done, take a photo and send me on the Telegram. On Telegram.
Okay. I don't know how to split out the 400 minus x.
Oh, can I see your working?
I haven't write anything yet because I cannot.
Okay. First, you need to be able to see. Do you know what are composite functions?
No.
Yeah, how you? But you definitely learned before. Like for example, f of g of x. Like let's say for example, f of x is negative x, g of x is ln. Sorry, ln of x. So what is f of g of x?
Negative ln x.
Exactly. So what's my outer function here? I will call it the f, right? Because it's outside. Then what's inside the f? It's a g. Maybe if I draw it more dramatically, it will be something like this. F is outside. Inside is a tiny little g. Then inside is a tiny little x. Can you see? Outer, inner. Okay, it starts shrinking down towards the middle. So here, likewise, there is an outer function negative, then followed by an inner function ln. How do we undo it? How do we reach the middle? The x is in the middle. You have to peel off like an onion, layer by layer. Start off with a negative sign, throw it away to the other side. Then you'll get. Oh wait, I skip a few steps. I need to show more working. Hold on a sec. Let me just crop this, shrink it down so I have more space. I'll copy the working over. I'll give you some hints, okay? Then you try again. Here, first layer negative, so you throw the negative to the other side. Left with ln 400 minus x equals negative 0.1 t plus ln 100. Correct?
Yeah.
Next layer, you got ln. Just now I told you before, e to the ln of x. Or actually, I asked you and you told me yes. What happens to e and ln?
That cancel out.
Exactly. You can just quickly check with your calculator. E to the ln of 5. E to the ln of 5. They'll cancel off, you're just left with 5. Then try with another example. E to the ln of 7. You just get 7. So if you generalize to x, you get x. Right? Correct?
Oh, then I can put plus minus. Then I will get.
Yes. Continue.
Okay.
E. Cancel 400 minus x with modulus. equals e power whatever. What's so special about this plus sign? Got a plus sign here. Can you
Like
split it up?
okay, it becomes times like ln 100.
E ln 100. What's e ln 100?
Oh, it's just 100.
Ah, so it's just 100. Correct. It's just 100 and you can solve. Make use of the trick. A equals to the constant. You will need this. You need to do this trick. If not, you will struggle when you're substituting the initial condition again. I think so.
So A is 100.
Not just 100, plus minus 100. Because here you got the modulus. Should open up the modulus or absolute value sign, and you get plus minus everything on the right. But I prefer writing it as plus minus 100 e power negative 0.1 t. Why? Because now I can see my A already. My A is right here. A is right here, plus minus 100. So this is A times e to the negative 0.1 t. Can? Can, okay, then you don't need to take photos and okay, good. So yeah, I basically wrote down the same thing. So A times whatever, A is plus minus 100. Okay, the E ln, the E ln 100 is just 100. Okay, good. Then maybe I should also join two lines like this. Cancel off. All right, so AE to the power of negative 0.1 t is 400 minus x. Make x the subject. Minus x bring over become plus x. A times E whatever bring over become minus AE to the power of whatever. Then you're left with 400 minus AE to the power of whatever. Okay? Okay, good. That's x. Then let's answer the question, the last question. What do they say? State what will happen to the population of the colony of insects eventually. What does eventually mean? T goes towards?
0.
No, eventually. Future.
Oh,
infinity.
oh.
Positive infinity means very, very big, large positive number. So basically in the future, T gets very, very big. Okay, positive big. So let's see what happens. Can you tell me what is so special about e to the power of negative? Then you times t. Any negative number to the power of t. How does the graph look? Okay, maybe it's a difficult question to answer if you cannot draw on a screen. So if we already know this is y equals e power x, right? Exponential. Exponential, you must remember, it's just increasing at an increasing rate, just like your compound interest, right? Your money will grow for you. You just keep growing faster and faster. Investment, you must. At the start, it grows very slowly, but eventually it will increase very exponentially. But how about y equals e to the negative x? This is just f of x, right? So e power negative x is really just what? F of what?
Negative x.
Exactly. Then what do you know about negative x? You did one question in the I paper already. Negative x, what happens to the graph?
Like it becomes decreasing.
The graphical transformation language is it reflects. It's being reflected about the y-axis, right?
Oh.
Right, reflect about the y-axis. So now the new graph will look something like this. And yes, it's decreasing. Okay, eventually it drops to
0.
very, very close to, but slightly above, but it's essentially 0, essentially. So this guy here, the A doesn't matter already because e power negative 0.1t will just go towards 0. Okay, maybe I just write down a bracket like this and then I write an arrow 0, means it's approaching 0. Then A times anything, you can just ignore it. Negative also doesn't matter. 0 you times -1 is still 0. Then what's 400 minus away a 0?
Like just 400.
Just 400. So that means that the graph, the description will be, it starts off slightly above 400 and then it rapidly declines towards 400. Okay?
Oh,
Yeah.
Above 400. Oh.
Yeah, it's slightly, you can also use a GC to draw this. So let's remember this equation, x equals 400 minus a times e to the power of negative 0.1t. Did you write it down?
Yeah.
Yes, okay, I'm gonna share Desmos with you. Do you know what's Desmos?
Yeah. The graph.
Yeah, the graph calculator, right? You can just draw the graph, I guess. This is a replacement for GC. So minus A could be positive 100. Let's say it's positive 100 times e to the power of negative 0.1 x. Instead of t, it's x. So I can zoom out a bit. Okay, what do you notice about the graph?
Oh,
oh, sorry, that's not accurate. Oh my goodness. It is not slightly above 100. No, it just starts off below 400.
So slightly below 400.
Yeah, not above, below. Sorry. And then it rapidly, I shouldn't say decline. I should say rapidly tends towards TENDS. I'll show you the words later. Here it's increasing towards 400 because I put in A to be positive 100. But the other case is when A is negative 100, which means this will become a plus. Then it will become the blue graph. Okay. So I think to be general, we should just say tends towards. Don't say decline, don't say increase, don't say decrease, just say tends towards. Move towards. But the more professional language is tends towards. Everybody uses that. Oh, you see the graph just slowly go, very, very quickly actually goes towards 400. Okay, you see, it's going towards 400 already, the y coordinate. 400.15, 400.075, 400.03, 400.012, and 400. Yeah. Okay. Let me just share back my iPad. Okay, sorry. So I shouldn't even say above. I shouldn't even say below. I should just say starts off near 400. Near 400. Then rapidly tends towards 400. This is the main point. Oh, I don't even need the rapidly, extra. Tends towards 400. That's the main point. Okay. Yeah, the population of the ants will become 400,000. Okay, next question. Let's go. Actually, let me plan a little bit. I think I only have time for one more question. Which one is better? It's gonna take some time. You want application question, right? So maybe I think I'll go through question 10. Okay, I'm just gonna go through question 10.
Okay.
Let's just skip to this question 10. Skip. Okay, question 10, go. So question 10, this one a little bit challenging. Let's take a look. So there was an island where initially there was no one living on it. So from here, they never use the word initially and no one for fun. They use it in, it's a math question. So these words have actual meaning. Initially, what does it mean? T equals what? Time. 0. And no one, they are talking about, eventually it will tell you that X is the population size in thousands. Okay, so again got thousands, so you have to be careful of the units. So X is just population size. If no one is living in it, it's how many thousands?
0,000.
Exactly, just 0. Okay, let's continue reading. The total capacity of the island is 9,000. So what does it mean about their maximum population? Max.
Nine. Yeah.
Just 9, not 1,000. Just 9,000. I'll drop 3 zeros because your units is in thousands. The population, they tell you, is increasing at a rate which is inversely proportional to the remaining capacity of the island. At the same time, the rate at which the population decreases is 1/20 of the population size. When the population reaches 4,000, it remains at this value. The population size in thousands is x at time t months. Show that dx by dt is this fraction. I think this is the kind of question that you're interested in, right? That they will find difficult. Okay, here it is more challenging. Just now, my water tank question, water is only going in, no water going out. Here, instead of water tank, it's population size. It's increasing and it's also decreasing at the same time. Maybe because of death or something, then the population decrease, or when people give birth and there are more people going in, then it will increase. So you have to account for both directions. The formula is really just dx by dt is equal to rate in minus away rate out. This is the only formula you need to remember. Okay. Then you need to figure out what's rate in, figure out what's rate out, put a minus in between. So let's go. Yeah, I just wrote down this t equals 0, x equals 0. 9,000 is actually 9 times 1,000. So maximum x is actually just 9. I'll just put it here. Then rate in, okay, rate of increase is the same thing. They told you already that it's inversely proportional to the remaining capacity of the island. So it's just 1/k times remaining capacity of the island. This fella over here, 9 minus x, is referring to remaining capacity. Do you know why?
The X is the amount of people at the time.
And 9 is the maximum. So remaining must be minus, right? Okay, this part okay? Yes, good. Inversely proportional is from Emax, from O level Emax. Like y is inversely proportional sorry, that's a short form of INV to, let's say, square root of x. Then what would your equation be? Y equals?
Is it k over the x half, like the square root of x? Like k divided by the square root.
Oh, yes, you're correct. Oh, sorry, I made a mistake here. This shouldn't be a k at the bottom, it should be a k on top. Yes, correct. K over square root of x, right? Yes? Yes. Then here, rate of increase. Can I continue?
Yeah.
Okay, yeah, the rate is increasing at a rate which is inversely proportional to the remaining capacity. Yeah, so the k should actually be on top. I'm so sorry. The k should be on top. K over 9 minus x. K over remaining capacity. Then what about the rate of decrease? Rate of decrease, they tell you, is 1/20 of the population size. So you just take the population size, divide by 20. Okay? X over 20.
Yeah.
Okay, good. So now you just want to get the total rate, dx by dt. You just take rate in minus rate out, or rate increase minus away rate decrease. So it will just be this guy, sorry, the k should be on top. K over 9 minus x minus away x over 20. Okay? Okay, good. So let's continue. So maybe I think I might have made a mistake. So I need to redo the question. Okay, I'll just start from scratch. Sorry for that. Give me some time to add a new page. Hold on. Yes. Okay, let's see. So sorry, give me a bit of time to do this.
No problem.
The question is over here. We'll cut it. Oh. And paste it here. Okay, Yes. So rate in minus rate out. Then that's why we have rate increase minus rate decrease. K over 9 minus x minus away x over 20. So this, how do you link it to this fraction here? How to link? It doesn't even look the same. That's when you need to figure out what is your you need to figure out something else, which is the last sentence they gave you. When the population reaches 4,000, it remains at this value. What does that mean? X equals what? 4,000. Sorry, X is in thousands, so you cannot have the 3 zeros, just 4. What can you deduce? Remains at this value.
Is it like the rate in and rate out is the same?
Which means what? Yes, correct.
The dx dt is
If these two numbers are the same and you minus them, what do you get?
0.
Equals to 0. Exactly. Yes, that's what they're telling you. No change, so it's 0 lor, for your rate of change. Can? Okay, good. So what that means is you can actually just sub x equals to 4 dx by dt equals to 0. Of course, you can just directly equate these two equations, make them equal. Then you get k over 9 minus 4, 0 equals k over 9 minus 4, minus away 4 over 20. Okay, then now you want to solve for k. Let's go. So 0 equals k over 5 minus 4 over 20, which is the same as k over 5 equals to positive 4 over 20. So therefore, k equals to 4 over 20 times 5. Just use a calculator, you get k equals to 1. Yes?
Yeah.
Okay, good. K is equal to 1. So now we can sub back in. Then therefore, we will get dx by dt equals to 1 over 9 minus x over 20. But it still looks different. You see, this one single fraction, dx by dt, they want us to show that dx by dt is this single fraction. Here we got two terms. How?
Can combine them.
Yeah, so we can combine them. So let's just multiply top and bottom by 20 here. Bracket. Then here we times 9 minus x. Right? Must make sure what is the same when you add fractions or subtract. Denominator is the same. Is that okay? Yeah. Yes. Yes. So 20 bracket 9 minus x. Numerator 20 minus away x times 9 minus x. Distribute the minus x in, you get 20 minus 9x plus x squared over 20 bracket 9 minus x. Let's just take a look at the original question. It's good to keep in mind what you're trying to show instead of just blindly adding the fractions. We need x minus 4 times x minus 5. Two factors, right? So what do you think we need to do to this guy?
Must factorize.
Exactly. And you just try a few times. You can realize that it's just x minus 4 times x minus 5. Okay?
Yeah.
Check, check. Okay, just expand, right? Factorization is just the opposite of expansion. X times x, x squared. X times minus 5, minus 5x. Minus 4 times x, minus 4x. Minus 4 times minus 5 become positive 20. Simplify, you get x squared minus 9x plus 20. Is it the same?
Yeah.
Yeah. Do you know how to use a calculator to help you to find?
Yeah, that one can.
You cannot? Okay, then I don't explain. Okay, good. So yeah, that's how you show the equation. Then you now need to find t in terms of x. Find t in terms of x. Wow, this one is quite long-winded. Quite long-winded. Let's go. How do we do this? Let's see. You want to find t in terms of x, right? It's to save you some time now. Usually they will ask you to find x in terms of t. Usual question is find x in terms of t. But here, other way around. Let's just write down the equation neatly again. I need more space, so I'm just gonna move it over. Can you tell me this one, is it separable differential equation or is it normal differential equation?
It's separable.
Separable, because dependent variable is x, so x is x. That means that you need to bring everything over. Oh, this whole thing, bring over. Yeah. Okay, let me just move it a bit more to the right. So bring over, what it really means. Let's just think of a easy example. Like let's say you have I don't know, x over y equals to 2 over 3. If you bring over, do you agree it's just 3 over 2? You flip the fraction around, times x over y equals to 1.
Yeah.
So same thing over here. It's just that instead of 2 and 3, we got a bunch of x minus 4 times x minus 5 and 20 times 9 minus x. Okay, it just gets a little bit more complicated. But no worries, just flip the fraction around like this. Okay?
Okay.
Times dx by dt equals to what?
1.
1, exactly. Okay, then now you integrate dt. Wow, this one I'm gonna take a lot of space. Wait, let me rearrange my working. I need more space. I'll move it all the way to the right. Okay, a lot of work on the left. Okay, let's go. So integrate 1 first, we get t plus c constant. Here, wow, very challenging. Let's take a look how we can simplify this. I see that we got 20 times 9 minus x. You know what? Let's just rewrite it first, like this. Here's how I'm going to present it. I'm going to pause here. I'll call this equation 1. Then I'll say let, I need a new page. Let I be the integral. Okay, let I be this integral. Okay, then we're going to work on this I. So let's simplify this. Let's just simplify the inner fraction first. 20 times 9 minus x over x minus 4 times x minus 5. Multiplying out, I get 20 times 9 is 180 minus 20x on the numerator, and denominator is, let's just copy down our working from before. X squared minus 9x plus 20. Right? Remember? X squared minus 9x plus 20. How to deal with this? How do you integrate this kind of fraction?
Cannot do the derivative.
The bottom is the derivative of the top. Sorry, the top is the derivative of the bottom.
Yeah, cannot do that one.
Maybe we can. Let's see. So differentiate x squared minus 9x plus 20. What do we get? 2x minus 9. How do you link this to this?
Times 10, but then
Let's see. Let's factor our negative sign first. You get 20x minus 180. If let's factor our 10 here. So we get 2x minus 18. Almost, right? But not so close. We need minus 9 here, is minus 18. But we can still salvage this. We can always force out a negative 9. Negative 10 times 2x minus 9 minus 9, right?
Yeah.
Distribute the, so you treat this 2x minus 9 as one lump, treat this negative 9 as a second lump. Then you distribute the negative 10 into the first guy and the second guy. What do you get? Negative 10 bracket 2x minus 9. Don't expand. Then the next one?
Negative 10, negative 9. Oh, so it's just plus 10 times 9.
Yes, which is 90. Okay? Then I skip a step. I never write down plus 10 times 9.
Yeah.
You get this, Negative times negative gives you positive, 10 times 9 gives you 90. Okay, good. So now we can rewrite it in this format. So we can replace the numerator with whatever we just found, this guy. Negative 10 times 2x minus 9 plus 90 over x squared minus 9x plus 20. What's so useful about this?
Can use the formula.
What formula? The formula, you mean integral of f prime of x over f of x?
Yeah, that one.
Equals to ln of f of x, right?
That one.
This will only work when this f prime is directly a derivative of the denominator. Here, only 2x minus 9 is the derivative. You still got a bunch of other things hanging around here. What should you do before you can use plus? In primary school, we learn how to add two fractions together become one. In JC, you must learn to work back. Exactly, split it up. So here's how you can split it up. Negative 10 times 2x minus 9. Yeah, this is not very intuitive, but I mean, if with practice, it becomes more intuitive. Then plus 90 over. Right? Work backwards, huh? Not very normal. Normal people will add two fractions become one. Here, you need to split 1 into 2. And then you can split that up further. Negative 10 multiplied by 2x minus 9 over x squared minus 9x plus 20. Plus, here is 90 over x squared minus 9x plus 20. Then if we try to integrate this, we have to integrate term by term. Can we integrate this guy?
Can.
And because the negative 10 can take out, then you can just ln. But how about this guy? 90 over x squared minus 9x plus 20. How to integrate? Do you remember? Every time you have a quadratic denominator, what are you supposed to do?
Must factorize. No, is it complete the square?
Yes, complete the square. Factorize into x minus 4. Sorry. Actually, there are, here is a constant, right? So actually, there are two approaches to this. You either complete the square or you do partial fractions. Complete the square will be faster because you already have a formula list. Okay. Should I show you both ways or should I just show you one way?
Can you show the complete the square? Well, it will work for everything, right?
Yeah, complete the square, it works for everything.
But the partial fraction only works.
Only works for specific cases, right?
Oh, okay.
Okay, can then I'll just teach a more general way, complete the square. Or should I go? Okay, I'll see if I have. Oh, it's already 5:40. Okay, no worries, fine. Yeah, okay. Let's just deal with this x squared minus 9x plus 20. Let's complete the square. So I hope you remember the procedure. Okay, maybe I jog your memory with a simple example. X squared minus 6x plus 17. How to complete the square? Trick. You see x squared, you drop the power 2, just leave x. You see minus, just copy down the minus. You see the coefficient of x, divide it by 2. So 6 over 2. I know it's a 3, but I'm just writing over 2 to help you see the general formula. Open and close the bracket, raised to the power of 2. Subtract away the same constant, bracket power 2. Don't forget there's a plus 17, so you also plus 17. Correct?
Correct.
Yes, okay, good. So same thing over here. X minus 9 over 2, open, close, open, square. And then you subtract away, open bracket, 9 over 2, close the bracket, square. What's missing?
The 20.
Yes, plus 20. Good. Okay. Then you now need to simplify. Type in the calculator for me this part here. What is this? What does this simplify to? There's a negative in front here.
719 over. Oh, wait, sorry.
Not correct.
Negative 1/4.
Negative 1/4, much better. Okay, negative 1/4. So that means that actually, every time you see a minus sign, right, do you think it's still related to tangent inverse? No. Okay, must remember, every time you got quadratic denominator, like quadratic, there are 3 cases. One is, No, actually just two cases. Sorry, two cases. It's either x squared plus some okay, let me give the more general case. Px plus q square plus some constant. Key idea here, key thing to take note here is the plus sign over here. It's a plus. It's a plus.
Oh.
Then you will link it to tangent inverse. Okay, it's related to tangent inverse. For the other case where it's px plus q bracket square minus a constant, you will link it to ln. Link it to the ln something over ln something identities.
Oh. Okay.
Look at your formula list. I think you can see, right? The ln over ln. Sorry, not ln over ln. It's ln over ln of something over something.
ln of something.
Yeah, do you have your MF36?
So is it the x minus a, x plus a?
Yes, correct. Those guys. They are actually the same thing. You see 1 over x squared minus a squared and a squared minus x squared, you're just multiplying by -1. Okay. So this is of this format when it's a minus, because you can now rewrite it as square root of k squared. Oh.
Yeah.
This is actually derived using partial fractions. Yeah. Yeah. So yeah, that's it. Just those two. Okay, but anyways, let's just focus on this. You can copy it later. I'll send you the PDF. Okay, so x minus 9 over 2 bracket square minus 1/4. You can actually rewrite as square root 1/4 square. Agree?
Yeah.
But what's a better way to simplify this one? Square root 1/4 is actually just 1/2. Luckily, don't need so many square roots. Simplify to 1/2. Can? Okay. How did I simplify to 1/2? If let's say that this was like a -5, you need to simplify as -5 over minus square root 5 square. Okay. Like here, 1/4 it will be minus 1/4 is actually minus square root 1/4 then square. Square root 1/4 is square root 1 over square root 4 with a square outside. And then square root 1 is just a 1, square root 4 is just a 2, then square. That's how I got -1/2 square. Is that clear?
Yeah.
Okay, good. So now that we got this, we can plug it back in. Then let's just simplify a bit more. So everything copy and paste, only the second fraction. The second fraction, the 90, I'm just going to factor it out in front. And the numerator changes to a 1. The denominator changes to whatever we just factored, this guy over here. X minus, no space. Wait, x minus 9 over 2 square minus 1/2 square. Okay? Now we are ready to integrate. I is equal to this fellow here. Then I'll just write down integral of copy and paste whatever we just factored. Dx. Can? Okay. Wow, I need more space. This is blocking. Wait.
Okay.
No space. Need more paper. Quadratic is this. I'll put it at the bottom here. At the bottom. Oh, it's gonna block my space eventually. Sorry. Wait a minute. Let me shrink this down now. Oh my god. Okay, like this. Okay, can good. Yeah. So let's continue. How to integrate this now? -10. You know you can integrate term by term.
Yeah.
Yeah. Okay, I'll just skip that step. Then you become -10 integrate 2x minus 9 over x squared minus 9x plus 20 dx plus 90 times of the integral of 1 over x minus 9 over 2 bracket square minus 1/2 square dx. Wow, so complicated. But finally, you realize this one is just ln, right?
Yeah.
So -10 of ln of the denominator with modulus plus 90 times of integrate this one. That's when you have to go back to your formula list, the 1 over x squared minus a squared. Oh, right?
Oh, is the long one?
Yes, correct.
X minus ax plus a.
Correct. So it's don't forget there's a 1 over 2a in front. Can you tell me what is my a?
The a is half.
Yes, correct. A is half. So it's 1 over 2a, which is 2 times half. Then multiply by ln of bracket fraction. What's my x minus a again? What's my a again?
The half.
What's my denominator? X plus
Half.
plus c. Finally, that's an integral. Are we done? No, we have to go back. This is just the integral. This is just the integral. We haven't answered what is solving for t solving for t. T in terms of x. Remember? Find t in terms of x. Wow, this question, 7 marks. Really putting in the work. Find t in terms of x. Okay, so what we have is dx by dt equals to this guy, and we are trying to find out. Well, we reach here, right? This guy here. So we only managed to find the left-hand side of this equation. Don't forget the right-hand side, there's a t plus c in equation 1. So now we have to substitute this fellow with I, which we found out to be this guy over here. Okay? Okay. So let's just copy down equation 1. I'll say sub I, or maybe I'll just call this 2. Sub I in 2. Never mind, that's too complicated. Sub expression 2 into equation 1, and I will be able to get, you see, left-hand side, replace it with everything that we found before. But actually, you don't need the plus c. You don't need the plus c because we already have 1 plus c here. You don't need so many. They are just arbitrary constants. You can just combine them. So we will get this guy. Okay? Okay, then now what you need to do, okay, I'll just clean this up. 2 times half is just a 1. And 1 over 1 is just a 1. So I'll just make it simpler. Less things to write, less messy. We are not done yet because we actually need to sub in the initial conditions to solve for C. So let's figure out what is the initial condition. Go back to the question. What did they tell us? They told us that when t equals 0, x equals 0. Remember? Yeah. We're going to use that. Okay, let's go. Sub t equals 0, x equals 0. Dot, dot. What do we get? Copy and paste everything. And then you replace every x with 0. 0, 0. And then you replace the t with 0 as well. So simplify. 0 squared, 0. Minus 9 times 0, 0. 20 is just ln 20. Don't forget a negative 10 in front. Plus 90 times of ln of this one. Oh, sorry, I forgot to put in the x equals 0. 0, 0, 0 minus half is negative half. 0 plus half is half. So that's just ln of negative 1. That's a problem. Why is it a negative 1? Let me just double check. I realized I made a mistake. Do you know what mistake I made? Let's look at the formula again. We have 1 over x squared minus a squared. But here, our actual formula is not x, right? It's what?
X minus 9 over 2.
So here it shouldn't be x. It shouldn't be x. Sorry. Let me use blue. Maybe I'll use green for correction. X minus 9 over 2. X minus 9 over 2. Okay. Which simplifies to ln of, let's see, minus 9 over 2 is, let's see, minus 9 over 2 minus 1 over 2. Oh, it's just minus 5. Okay. 10 over 2. Then minus 9 over 2 plus 1 over 2 is actually minus 4. So x minus 4. Okay. Can Okay, then x minus 5 and 4. Continuing, we get 5 and 4. It's still negative. That is not supposed to be the case. I think I did something wrongly. Uh-oh. Sorry, I might have done something wrongly. Wait a minute. Sorry. Seems correct so far. Okay, something is wrong. Number 2. Okay, I'm not too sure what is going on with this mistake I made.
Oh.
Let me see again. Initially, there was no one living on it. So t equals to 0. The population should be 0. So x should be equal to 0. Hey, something is wrong. Sorry about this. There is a mistake with this part here. It becomes a negative 5/4, which is undefined. So something is wrong with my working, but I'm not sure what. I need x1. Oh, the condition is for x to be strictly more than a. Okay, I am not too clear about this. You can only use that formula if your x minus 9/2 is strictly more than 1/2, which means you need x to be strictly more than 10/2, which is 5. X to be strictly more than 5. But that is not exactly the case, because what's my possible x value? My population could reach 4,000, which is not possible, which means that I cannot actually use that formula. Okay, let me just okay, let me make this correction here. Over here, this part. Oops, sorry, I should leave that. Not allowed to use as x minus 9/2 more than 1/2 is not satisfied. So I think actually the better way to go about doing this is to use partial fractions.
Oh.
Can I show you the partial fraction method?
Oh, sure.
This one? Can I hope you still have time.
Yeah.
Okay, let's go. So here we are trying to figure out what is the integral of this guy here. We're trying to figure out what's the integral of this guy. So I will do partial fractions first. So let's say 90x squared minus 9x plus 20. We factorize it as 90 over x minus 4 times x minus 5. So that case, right, we can factor it as a over x minus 4 plus b over x minus 5. Multiplying throughout by x minus 4, x minus 5, we get 90 equals to a times x minus 5 plus b times x minus 4. This is from A max. So I'm going a little bit faster. I hope you don't mind. Okay, then a few ways we can do this. One way is to pick a good value of x. I chose x equal to 4 and I will choose x equal to 4 and x equal to 5. When x equal to 4, sub in, we get 90 equals to, let's see, 4 minus 4 is 0, plus 4 minus 5 is -1 times a, which implies that a equals to -90. How about when x equal to 5? 90 will be equals to 0 plus 5 minus 4 is 1, so it's just 1 times b, which is b. implying b equals 90. Replacing it back in. So a here is a negative 90, b here is a positive 90. I think this is much better, much better. This means that I can now immediately find my integral already. Integral of 90 over x squared minus 9x plus 20 will be equal to the integral of the partial fractions. Correct? Because they are equivalent.
Yeah.
You split it into two fractions. Then you try to integrate this guy term by term. So negative 90 can factor out. You get ln of modulus x minus 4 plus 90 times of ln of modulus x minus 5. Okay? Much better. Okay, much simpler. Yes, this definitely works. Partial fractions is way faster. Okay, instead of trying to memorize the formula.
I still have to tell which one I should use.
You need to satisfy the rule. Over here, right, you have two versions. There, notice there's a bracket on the right side, x more than a for the first one and modulus x less than a.
Yeah.
You need to satisfy those rules first. If you don't satisfy it, sorry, I forgot to check that. If you don't satisfy those rules, you are not allowed to use the formula.
Oh, okay.
Yeah, if not, you will end up with like this problem here where you will have a negative value, which is undefined. It shouldn't be the case. Okay, so I made a mistake here. This is a mistake. I used the formula when I actually couldn't use it. You need to satisfy this, which means x has to be more than 5. But my x can be 4,000, which means it fails to satisfy this rule sometimes. Which means I am not allowed to use the formula.
Oh, okay.
Okay, carrying on. Okay, now that I have found the actual integral of the 90 over x squared minus 9x plus 20, I can, let me try again. So I should actually be equal to, okay, if I can just copy down all the working that's needed. Let me just draw a cross to mark out the parts that's wrong. You can read my mistake later. I equals to this one, and finally we can replace that integral with negative 90 ln x minus 4 plus 90 times ln x minus 5. And this guy, of course, okay, the front term, sorry, I'm moving around a bit, moving around a lot. I hope you're not confused.
It's okay.
Yeah, so this part here is okay. This front part here is okay. We get negative 10 ln of modulus x squared minus 9x plus 20 minus away 90 times of ln x minus 4 modulus plus 90 times ln of x minus 5. That's the answer for the integral I. Then we now need to find out what is equation 1. Okay, let me copy down equation 1. Wow, this is equation 1. Then we can finally say I'll call this equation 2. Sub 2 into 1. Then finally we will be able to get our expression, our t in terms of x. Now there's still an unknown c. How do you solve for c? You need to replace with initial condition. What is the initial condition?
The 0, 0, that one.
T equals 0, x equals 0. So now we substitute that in, we get negative 10 ln of 0 minus 0 plus 20, so 20, minus 90 times ln of 0 minus 4 is modulus of negative 4 plus 90 times ln of modulus of negative 5 equals t plus c. So, sorry, t is 0. Sorry, t equals to 0. So here, this is when it's very important to put in the modulus, because modulus negative 4 will convert it into positive 4. So ln of positive 4, then that will be defined. Likewise for ln negative 5. Must have the modulus, if not, this part will have a math error. Okay, then we can solve for c now. So let me just simplify a bit more. Negative 10 ln 20 minus 90 ln 4 plus 90 ln 5 equals to c. So c is equals to this quantity here. I can clean up a little bit using logarithm rules. So this would be minus ln 20 to the power of 10 minus ln 4 to the power of 90 plus ln 5 to the power of 90. Combining them, I get ln 5 power 90 times 20 power 10. Oh, sorry, not times, should be at the denominator. Times 4 power 90. Okay, this is logarithm rules, right? Positive terms will appear on numerator, negative terms will appear on denominator. I know I'm going quite fast, huh? Hope you're still okay. Yeah. So that is the constant. Then finally, we can replace this C over here, and then we can solve for t equals t as a function of x. Okay, let's go. So copy and paste. And finally, replace the C with what we just found. Here, plus. Then you want to solve for t, you just have to rewrite it, bring the ln over. So we become minus ln. So we get this entire expression minus away ln of whatever, which is your C value over here. And finally, we are done. Okay, it's not done yet. This is only the first part of the question. The first part of the question asks you to find t in terms of x. This part, okay already. Now we need to find the time when the population reaches 2000. Take note that x is in thousand. So when it's 2000, it means x is equal to what?
2.
2, exactly. So you have to now sub in x equal to 2 and find the t value. Okay, that's what the question is asking you to do. T equals what? When x is equal to 2, find t. Okay, that's what they're asking you to do. Okay, let's go. So last stretch. Okay, when x equals 2, t equals question mark. So we're gonna substitute x equal to 2 lor, that's all. And honestly, I think this one, you don't really need to simplify it. Leaving it as it is fine. Because I mean, if you want, you can key into the calculator on your own. I will leave that to you.
Okay.
This part here might be a bit difficult to calculate, but I think leaving it like this is fine already. And that is the answer. Okay. River Valley. All right, let me stop the recording.